guys, welcome to lesson 24, predicting grams of product from grams of reactant. Now in lesson 23, we learned how to predict how many grams of a product we could be given from the amount of moles in reactant. Now we're going to learn to predict the amount of grams from a product from a given number of grams in a reactant. And if you can say another step, you are right. So let's look at our example. We start out the same. Oh, here's our example. We have 350 grams of ammonium nitrite. If we allow it to decompose into water and nitrogen, how many grams of water might we expect? So we write our problem in a balanced equation right here, and it gives it to you on the book. On page S231, you can always check that. Then we locate the products in question, the ammonium nitrite, to the water, and we find that it has a 1:2 mole ratio. Normally we would apply the math here, but since we're looking at grams, we have to turn it into moles, and we know how to do that by finding the formula weight. So we break down the nitrogen, the hydrogen, the oxygen, we multiply it by its atomic mass, we add it together, and we get our formula weight. Again, if you're still working on this, you can always put this on a scrap piece of paper for extra practice. Then we do something fancy. Then we need to know how many moles convert into that many grams. So we have 1 mole is 64 grams equals, we don't know how many moles in 350 grams. So we cross multiply here. So 64x equals 1 times 350. So 64x equals 350. We divide 350 by 64, and that gives us 5.46 moles. Then we add our math. Then we take our mole ratio and we apply it. 1:2. We get 5.46 moles is the 1. That's the reactant. To times 2 is 10.92 moles of your product. Well, here's your actual stuff. So you end up with 10.92 moles of water. Then we have moles. If we look back at our problem, they're asking us to predict grams. So you're right, class. We take the moles, we put them back into grams. We know that 1 mole of water equals 18 grams because that's the formula weight of water. We've done that in a couple of chapters before. So we take that formula weight, we multiply it by how many moles we have, which we determined up here. So 10.92 moles times the 18 grams per mole equals 196.56 grams of water. And we are done. So the steps on the bottom of page S233 summarize it nicely. We write the balanced equation, we're used to that. We locate the compounds, we're used to that. We determine the mole ratio, we're used to that. Before we apply the mole ratio, we convert the grams to moles. Then we apply the ratio to get the mole of the product. Then we convert the moles back to the grams, and then we're happy we've done all of our steps. Again, you have annotated answers for these. If you're having trouble finding the balanced formula, go ahead and look at that as soon as you have that written with your practice. If you want to check every answer at the end before you move on to the next one, that's a good idea. And don't forget about those diatomic gases. You guys have a great week. I'll see you soon.